Hi guys, welcome to my channel once again. Today we will be discussing on the problems related to heights and distances. Okay, so in our last class, in our last session, we have discussed about the heights and distances, the concept, and by now I think hope you all are aware of what is angle of elevation, angle of depression, and the reference horizontal line and the distance from the object to the observer, like all those the basic terminologies. So hope you all are aware by now. So in today's session we will be discussing on the problems related to heights and distances. Okay, so let's start. Now let's start up with the first problem. Now let's discuss the very first problem. Now a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Okay, so now what is it states? There is a ground above which there is a vertical pole from which there is a 20-meter long rope. How much is this? 20-meter long rope which is tied on the ground very tightly. Now what we need to find? We need to find the height of pole. Okay, so that means we need to find out h, which is nothing but height of pole. Okay, now what is the height of pole? Now that is what we need to find out. If the angle made by the rope with the ground level is 30 degree, if this is 30 degree and the rope length is 20 meter, what is the height formed? Now we all know, we have seen in previous sessions of trigonometry as well, what you need to apply. You have, there is an opposite side, there is an hypotenuse. So opposite is nothing but the height of pole and hypotenuse is nothing but length of the rope. I hope by now you need to know what trigonometric identity we should use, right? Which is sine 30 is opposite by hypotenuse. I think now you all know what to do and how to do it, because sine 30 is nothing but how much? Half. This is h by 2, sorry 20. Now if this 20 goes here, what will be the h? H will be 20 by 2, which is nothing but h is 10 meters. So therefore you need to write it in words. Height of pole is 10 meters. Easy. So this is how you need to solve it, guys. That's it. Look, those problems looks very complicated. It just looks complicated, but it is actually not complicated. I'm telling you, if you're able to solve, if you're able to understand line by line, and if you're able to extract the given data very easily, like drawing the rough diagrams like this, it will become very easy. I'm telling you, very easy. Now next, solve another problem. I'll just read out the problem. Now the angle of elevation of the top of the tower from the point on the ground, which is 30 meter away from the foot of the tower, is 30 degree. Find the height of the tower. I'll just draw the diagram. You need to solve it. I'll just reading out the question once again. The angle of elevation of the top of a tower from the point on the ground. Once again, there is a ground. From the point on the ground, to the tower. There is a huge tower. The angle of elevation is from the foot of the tower is 30 degree, and this is 30 meter. The point is 30 meter away. Now you have got the adjacent side, and what you need to find out is here is find the height of the tower once again. So you need to find the height of tower. You have adjacent side, you need to find out the opposite side. So which trigonometric ratio you will be using it? You need to solve it, guys, because tan 30, I'm just giving the hint, you need to use tan. Simple. And you need to find out h. Okay, I think this you can do it by yourself without any stress. I hope so. Now the next sum. Now let's do it. Now the next sum goes, a kite is flying at a height of 60 meter above the ground. Okay, I'm reading the question very slowly. Now think this is the ground. This is just a symbol to to give the feel of ground, so that okay. Now there is a kite. There is a kite flying, which is how much? 60 meter above the ground, and the string attached to the kite is temporarily tied to the point on the ground. So now the string is tied temporarily to the point on the ground. The inclination of the string with the ground is 60. So the inclination with the ground of the string, now this is the string. So what is the inclination angle? Is 60 degree. Okay. Find the length of the string, assuming that there is no slack in the string. So what you need to assume is no slack. I think no slack in the sense the string is absolutely tight. There is no loose, or there is no part which is like hanging. It is solid straight and solid tight. So you need to assume that it is solidly fitted to the ground. Okay, so just assume that condition. Now I think by this time you should know. And what you need to find this string. What is the length of the string? I'll just write it as LS, length of the string. I think by this time you should know what identity you should use. I mean, what trigonometric ratio you have to use and how you need to calculate the length of the string. Look, guys, it will end up in the normal way. The solutions are going to be in a normal way itself. But what you need to find out is, or what you need to draw from the question is this. The diagram is very, very important, I'm telling you. This, if you're able to sketch the given data, your 70% of the job is done. I'm telling you, if you're able to fetch the rough diagram from the given data, I'm telling you 70% of the job is done. Rest 30% you need to just apply the ready-made formulas with ready values. Okay, easy. Now just go ahead and do this. Now the length of the string is nothing but a hypotenuse. So this is hypotenuse, and you have got the opposite side. So which one to use? Sine 60 is opposite, which is nothing but 60 meter, and length of the string. Correct? Now what is sine 60, guys? Now sine 60 is root 3 by 2 is equals to 60 by ls. This implies ls cross multiply, correct? ls is nothing but 60 by 2 root 3. It's not 60 by, it is 60 into 2 by root 3, which is nothing but 120 by root 3, correct? Now from here, there is a small change, guys, how you need to do it. I'll just show you in this box. Now what is this root 3? I mean, 3 can be written as root 3 into root 3, right? Can I write it like this? Correct, right? 3 can be written as root 3 into root 3. Now if I want to get 1 by root 3, what I have to do? Root 3 by 3, is it the same as 1 by root 3? Correct. Now what is 3? Root 3 into root 3. 1 root 3, 1 root 3 get cancels out. I'll just show it over here. 1 root 3, 1 root 3 cancels out. And what you'll be ending up with is 1 by root 3 itself. So 120 into 1 by root 3, can I write it as, I'll just show you in the next one. So 120 by root 3, I can write it as 120 into root 3 by 3, correct? I'll just show you how it comes. 1 by root 3 is equals to root 3 by 3. So 3 can be written as 3 root 3 into root 3. 1 root 3, 1 root 3 get cancels out, so it is 1 by root 3 itself. Look, I've got the answer, 1 by root 3. So instead of just 1 by root 3, I am writing it as root 3 by 3. Got it? Now 3 ones are 3, 40 is a, what is the answer? 40 root 3 meter. Easy. Or you can also, like, there is also a way which is just nothing but 120 by root 3 or 40 by root 3. You will be ending up with the